quadrilateral ABCD is a trapezoid where the lengths of AD are 15, AB is 50, BC is 20, and the altitude is 12. What is the area of the trapezoid? The first thing I notice is that I can draw a vertical line from point A down to the line CD such that it creates a 90-degree angle. Same with drawing a vertical line from B down to CD such that that also creates a right angle. And both of those distances will also be 12. So then I can find the smaller lengths of the legs of my right triangles as follows. Giving me 12 squared plus b squared is 15 squared. Or 144 plus b squared is 225. Subtracting 144 from both sides, b squared is equal to 81. So the length of this leg is 9. Following the same pattern for the other triangle, I will have 12 squared plus b squared is 20 squared. Or 144 plus b squared is 400. Subtracting 144 gives me b squared equal to 256, and the square root of 256 is 16. So the length of this leg is 16. We have two different options that we could use. We could decompose our trapezoid into two triangles and a rectangle and add their areas together, since finding the area is additive of composite functions or composite shapes. So the area of this trapezoid could be the area of the triangle on the left plus the area of the rectangle plus the area of the triangle on the right. That would give us half times base of 9 times 12 of height plus the area of the rectangle, 50 times 12, plus the area of the triangle on the right, which is half times 16 times 12, giving us 54 plus 600 plus 96 for a total area of 750. Or we could use the area of a trapezoid formula, which is half times height times the base 1 plus base 2. So half times the height of 12 times our base of 50 across the top and our base of 75 across the bottom, which is 9 plus 50 plus 16, giving us half of 12 or 6 times 125, which also gives us 750. Let's use the Pythagorean theorem to help us find the distance from point A to point B. Notice this is a diagonal length crossways, so we're going to need to find some information. First, we need to find the distance from point B to the corner point C that we label, so that we can create a nice right angle. But in order to find length B to C, we need to use the triangle that's listed there and find that length B to C. I know that the bottom base is 12 and the other leg is 5 yards. So using the formula 12 squared plus 5 squared equals x squared, we get 144 plus 25 equal to x squared, or 169 equals x. Taking the square root, I see that x is equal to 13. So now that we know the base of our right triangle, we can use this now to identify the length of A to B with our new triangle that we have. We know that the bottom leg is 13. We know that our height of this triangle is 84. We need to find the hypotenuse. So 13 squared plus 84 squared is x squared. 169 plus 7,056 is x squared. 7,225, if we take the square root of that, we see that the length from A to B is 85 yards. Homework. A spider walks on the outside of a box from point A to point B, then from point C to point D, and finally to point E as shown in the picture its path. Draw a net of the box and map out the path of the spider on the net. To verify your path is correct, cut out the net and put the box together in a three-dimensional way. How long is the path of your spider? Scan and upload your work in the discussion board Spider Path and comment on the work and ideas of at least one classmate. We can extend our ideas of finding the volume of prisms to finding the volume of a cylinder. We know that the volume of a prism is base times height, where b is the area of the base that we're looking at, and h is the height of the object. The volume of a cylinder is also base times height, where b is the area of the base and h is the height. Except this time the area of the base of a cylinder is a circle, so we need to know the formula for the area of a circle, which we know is pi r squared. The base, or the area of the circle, is 3.14 times our radius of 8 squared, giving us 296 meters squared. We now need to take that times the height of our cylinder, which is 10, for a total volume of 209 6/10 meters cubed, since we're in volume. A cylinder has a diameter that is 8 inches long and a height that is 2 inches tall. What is the volume? So we first need to know the area of the base. So we need to know the area of the circle that it's in question. So 3.14 times the radius. Now it gives us the diameter. We know that the radius is half of the diameter, so 4 squared, giving us 50.24. Now we can take the area of our base and multiply it by how tall it is, which is 2, giving us 148 thousandths inches cubed. We can extend our ideas of finding the volume of a cylinder, finding the volume of a cone. The volume of a cone is 1/3 the area of the base times the height. So find the volume of the cone rounding to the nearest thousandth. The area of our base is still the area of a circle, so pi r squared. So 3.14 times the radius of 2.7 squared gives us 22.89. We need to take that times 1/3 and times the height of this cone, which is 4 3/10. Multiplying them all together, we see that we get 32 81 thousandths inches cubed. We can further extend our ideas of finding the volume of a cylinder to find the volume of a sphere. The volume of a sphere is 2/3 the volume of a cylinder. So if we know that the volume of a cylinder is pi r squared times height, and in particular our height here is 2r, since radius is just halfway and 2 radiuses would be all the way across. We can combine like terms and multiply or rearrange. Multiply our whole numbers to give us 4/3, and our radius squared times radius is radius cubes. So therefore the volume of a sphere is 4/3 times pi times radius cubed. So let's find the volume of this sphere here, which is 4/3 times 3.14 times the radius cubed, or 5 cubed. Multiplying all together gives us 523 3/10 centimeters cubed. Find the volume of the hemisphere. Well, a hemisphere is half the volume of a sphere. So therefore, the volume of a sphere is 4/3 pi r cubed. We want half of that, so half of 4/3 pi r cubed, giving us 2/3 pi r cubed as our formula. Plugging in 3.14 for pi and 2.1 for radius, we see that this would be 19 4/10 centimeters cubed. Complex volumes can be found by identifying the figures and adding their volumes together, because adding volumes or finding the volume of complex shapes is additive. A grain silo is designed as a cylindrical container that has a cone-shaped bottom so that it empties easily. If the silo is filled all the way to the top, how much grain by volume is it holding? So we have the volume of a cylinder plus the volume of a cone to identify the total volume altogether. So our total volume would be the volume of a cylinder, pi r squared h, plus the volume of a cone. So plugging in the information particular to the cylinder and the cone, we get 3.14 times the radius of the cylinder, which is half of 18 or 9, times the height of the cylinder, which is 25, plus 1/3 times pi 3.14 times the radius of the cone is also 9, except the height of the cone is 10. Simplifying, we see that we end up with 6,358.5 plus 847 and 8/10. Adding them together, we see that we get 7,206 and 3/10 feet cubed. Print the homework file included in the practice problems homework Dropbox. Complete the problems as outlined within the homework pages, taking care to show all of your work. Scan and upload your documents back into the practice problems Dropbox.